Hello everybody, my name is Eric Daniels, and today we're going to be presenting our bowel valve for SIMS for 4345. Amanda Bueller and Adel Orndagel are all in this group, and this is what we you'll see our abstract, our research, solid modeling, the assembly, and the machining process for our project. The description of our project is you have a ball valve. We started with an initial design, a traditional ball valve, flanges, fasteners, valve body, and then a backside flange for fastening. We kept with the same ball valve, a 2-inch ball valve, and what you'll see is we reduce the body parts by 1, so we have two valve body parts that are sealed in with a compression seal. Some of the details, like I was saying, we use the casting process for a more seamless design. It's fewer parts overall, and we look to reduce the points of failure in the valve body itself. This is going to be our initial design, and we'll go and look at this in a little more detail in a minute. But this is your more traditional ball valve. You see backside flanges, front side flanges. You see the ball valve, they're the valve body itself, and then you see the fasteners, the nut and bolt system with the handle. You see the locking mechanism, and then how it rotates, open and close, parallel being open and perpendicular being closed. This will be our new design. What you can see here is you see the main valve body to the right, and then you above it you have its port top, and you have the thread pin, which then goes into our ball valve itself, and then it is joined by the handle, and then it is locked into place with a locking nut. It's used, that's what we use to open and close the ball valve, with that same parallel is open and perpendicular is closed. The two valve bodies are joined, and when they're done so under high compression, that seal is our bond, is our seal, is our fastener. So we reduce our points of failure on the valve body to those points, and then you can see that we have thread ends on the back end on the main ball valve, and I'm not sure if you can see it in this picture, but we'll look at it in Autodesk. Threads on the back end as well, so you could thread these in for petro, for oil and gas, for water treatment, you name it. So here in Autodesk, here's our initial design, and what you can see here on it, this very traditional ball valve, flow through here. You have the fastening systems, and then the handle. And so let's just take a look at it here. And what we have is what we saw earlier. Make this a little easier to see. We have our backside flange, our valve body, and our front side flange, and then we connect with the bolts here, and then here's our handle, open and close with the locking mechanism. So moving over to our new design, as you can see, the coloring, we upgraded from stainless to brass to help with some more flow resistance. And come over here. What we have here, explode this out. There we go. So let me bring this over here. So what you can see is we were showing you in the PowerPoint. Here's our main valve body, that compression seal, and then the ball of the valve itself, locking pin, handle, locking nut, and then the secondary ball valve. So when we join these together, when we join these together, you can see this is our assembly here, and you can see the threaded in here, threaded in on the back. And what you'll notice here is this isn't a true 2-inch through valve. This is, when we get to the ball valve, we'll reduce down. So that is something of note. And then we come over here, and so what we have here is going to be the animation of our model. And you'll see the opening and closing. You'll see the 90 degrees is the perpendiculars when it's shut, and parallel is when it's open. And you'll be able to see this is the ball valve in action. So we'd like to thank everybody for taking a look at our project, and we're looking forward to hearing some of your feedback. And thank you again. Thank you to Amanda. Thank you to Adel. Thank you to the professors. This has been a great course, a very interesting course. Learned a lot, and excited to keep using this great tool, Autodesk. Thank you.